So what we're going to have to do today is just maybe wrap up everything about spectroscopy, okay? And then the one where I will ask you to use some sort of a simulator. So if you have the slide, vibrational spectroscopy, so there is some sort of an exercise in one of the slide there. I'm trying to share it to you. Where is it? Where is it? This one. This portion. Okay. So when you go to this link, which I'm going to share to you, where is it? No, not that one. Oh, no, not that one. So this is how the links look like. Okay. So if you go here, you can do some sort of a search, or maybe you can put some of the structure that you have here. Demo IR. So do you see? So if I'm going to put here, let's say a benzene. So if I ask it to search, it will give you all the one that contains this aromatic ring. So what you're going to do is, if you're going to choose one of them, it's going to bring you to, let's say, maybe I'll just use benzene, like this one. I can have this acetonitrile, benzonitrile. So as you could see here, so there's a, I don't know. Diagram. Just trying to get my mouse. Full screen. Okay. So if I want to do a search here, so I just click. Now I have to teka lang, ulitin ko lang na ano yung pag-browse ko eh, min-maximize ko lahat. So if you want, let's say, to look at the difference, let's say, of this. Oops. Ayan. Ayan, straight line. So this is a para-silene. So if you want to look at the difference of that with the other isomer, so this is one way to look at it. So the good thing with this one, you can download this. Okay. And I'm not sure if you can open it, JDX yung tawag na software. If not, then the way I ask my student here, to do this is just to save it as a photo. Okay. And then I'll ask them, let's say, to compare with the other isomers that we have. So here, medyo dalawa na yung ano. So this is the difference between the para silane and this one, but I just want the silane. And then if I want, let's say, to do this thing here, instead of the para, I want to go with the meta. Oops. So I can do some sort of a comparison between them. Okay. So the way that we use this vibrational spectroscopy as seen there, or what we call recorded, this is all for qualitative analysis. Okay. We don't usually use your vibrational spectroscopy for quantitative analysis. And just to show you some of the stuff that we did, I'm trying to open some file here. Where's the paper? So we attempted to do some sort of quantitative analysis, okay, using Raman spectroscopy. And the way that we do it is we use the so-called silane. So I don't know if you could see here, okay, a paper that we publish. So we're trying to use here a portable Raman spectrometer, and we try to use silane isomers to see if we can quantify them. So based on our analysis here, we try to look at the so-called unique peak, okay, and common peak. And what we do is we try to do some sort of a normalization, taking the ratio of this unique peak with the common peak, hoping that we can have this what we call the intensity, the ratio of the intensity. And what we do, we get the R value, wherein we compare the intensity from the normalization of this mixture over the intensity of the normalized what we call pure silane. So the way that it looks like is this one. So here we have both experimental and theoretical calculation. So I try to see if I would be able to show you some software that we utilize. So I'm opening a software. So this is what we call a Gaussian software that wherein you're going to put something to it. Let's say if you want water. So you can put the water there. Kita niyo yung ano, water molecule? Can you see it?
Yes.
Okay. So I want you to see what will I do with this one. So I can do some sort of a calculation. Okay. I have kayanin. So I put, let's say, some command here. So you see some sort of a calculation setup. Nakikita niyo ba yung kiniklik ko?
Yes po.
Yung, let's say right now, the highlight is a DFT. Okay? And then 631G. I'll just try to use water kasi maliit lang yung ano niya. So at least if we do some sort of a calculation, wait, I have to cancel because what do I need? Job title, oh, okay. So I need to look at this optimized frequency. So as you could see here, I will compute both the Raman and the IR will come out right away. So if we're going to look at this, okay, so I'm just going to put here, I'm just trying to show you how we do this stuff here, where you get theoretical results and compare it with experimental results. So it might take maybe 5 minutes, okay? Because if you're going to look at the discussion that I have, it's mostly more on this molecular vibration. So that's the unique thing of this, what we call IR and Raman spectroscopy. And I'm not sure if the IR, we have an IR during our time there, okay? And I'm not sure if it's still functional. It is very useful in what we call getting some of these, what we call peaks of the functional groups, okay? So we're going to get back to it. Okay, so you see, it's now completed, okay? So what I'm going to show you, so I share ko doon sa, so you see this big red one. So look what I'm going to do. I right click it and then you see the results and I go to the vibration and look what will I do. I'm going to click this what we call mode. So ibig sabihin ilang modes yung meron dito, 3. And it will show you what modes that they have. So start animation. So do you see a molecule moving?
Yes, po.
Okay. So if I'm going to show you the spectrum, so you see an teka lang. Kita niyo yung IR spectrum? Here, do you see this IR spectrum?
Yes.
Okay. So yung naka-highlight ngayon, so if you're going to look at this is the peak around 15 to 1600. Okay? So, wave number. So, ang gagawin ko ngayon, papakita ko sa inyo kung ano yung frequency na yun. So, I'm going to show you the molecule. Okay? So, anong tawag natin dyan? Is that stretching or bending? Kita nyo ba?
Bending po ba, sir?
Okay. So remember, in the lecture that I have, the type of interaction that you have, kapag sinabi mong stretching, okay, what happened is they remain in place. Yung ano lang yung atom lang yung parang nagmo-move. Okay, but when you do what we call bending, okay, there's some sort of angle, this what we call movement. So that is what we call bending. Okay? Now, I'm going to go again doon sa spectrum. So you could see, that's the one that you can see here. Kita nyo, both IR and Raman, they have the same peaks. Yun nga lang, dito sa nakikita nyo, yung nakikita nyo movement kanina, mas ano siya doon sa IR compared doon sa Raman. Okay? But if we're going to move it on the other one here, around 3500, so tingnan nyo ano yung movement. What movement is that?
Stretching po.
Anong klaseng stretching?
Symmetric po.
Okay, so that's a symmetrical stretching. And between the IR and the Raman, mas ano siya doon sa Raman. Mas mataas yung kanyang peak. So if you're going to look at this, hindi kasi sabay-sabay pwede, kaya kailangan ko isa-isahin sa inyo. So if you're going to look at this, so there's where you see the peak. Okay. Now, if I'm going to move the other to the other peak, so tingnan nyo ano mangyayari doon sa molecule. Okay? So anong tawag dito sa movement na to?
Asymmetrical stretching po.
Asymmetrical stretching. So I can just only use water, okay, for now, because I just want to show you how you have this some sort of a tool that you can use to determine the theoretical what we call vibration. Okay, so I'm not sure if you have this kind of tool in UPLB. Although I left a copy of this that can be installed in one of the professor in UP in IC, okay, and one of the professor also in IMSP. And this what we call software that we have, this is what we call a Gaussian. Okay, so Gaussian can have what we said a lot of calculation. Are you familiar with the HOMO-LUMO? Familiar ba kayo dun sa HOMO tsaka sa LUMO? So, anong tawag nun kung familiar kayo? Ano yung HOMO? Ano yung LUMO? O sige nga.
Yung HOMO po, sir, highest occupied molecular orbital.
Okay, so that's the highest occupied MO. Okay? Tapos yung LUMO naman
Lowest unoccupied MO po.
MO. Now, I know in this what we call software, I'm not sure if I can do it, but maybe next time, we can look at the results. So I'm not sure. I want to see the results. View results. Wala, hindi siya kasama doon sa ano ko. So ang ginawa ko lang dito is charge distribution. Because there's also a way where you can determine this HOMO-LUMO thing using this what we call software. But it depends on how you use it in terms of this what we call calculation. But for me, I just use it for geometrical optimization and vibrational determination. Okay, I can also use, let's say, nitrogen. So what do you think about the nitrogen? Are they IR active or Raman active? Ano sa tingin nyo? Ano sa tingin nyo yung nitrogen? So let's try to build a molecule out of nitrogen. So if you have a nitrogen, okay. So what will I do with this? I'm going to make this into a triple bond. So I'm building up the nitrogen. Teka, hindi nyo ata nakikita yung nitrogen. So this is the nitrogen that I have. Okay, so ano yung prediction nyo? Okay, dito sa nitrogen. Is it a Raman active or an IR active? So I can show you the calculation. It will take only a short time kasi nga maliit lang yung tinatawag nating molecule. Okay? So I would save this one. Wait. Okay, artifact. Okay, I can do 321G for this purpose. So nitrogen. So if you're going to look at the nitrogen, okay, titingnan mo yung kanyang structure. As you could see, it's just like this one, right? So if you're going to look at that case, you could say that it is what? It is only Raman active, okay? Kasi if you look at the nitrogen, does it has a dipole moment? May dipole moment ba ang nitrogen? And I'm going to show you the results of the calculation. So merong message doon na sinasabi, linear molecule detected unable to orient dipole derivatives. Okay, so let's try to see how we're going to look at its vibrational spectroscopy. So kukunin ko yung results, vibration, okay? And if you're going to look at here, meron siyang vibration. But the question now, what caused this vibration? Ito ba ay IR or Raman? So we're going to look at the spectrum. So as you could see, kita nyo ba yung spectrum? Hindi. Hindi siya active sa IR. Right? Kita nyo yung spectrum? Yung IR spectrum?
Yes po.
Okay? So hindi siya active sa IR. Wala siyang peak sa IR. But in Raman, you have a peak. And it's around what? 2600. Why is it at 2600? Anyone? Because it is a... Ano ba yung nitrogen natin? Ano yung band niya? Anong band ng nitrogen natin? Anyone? So if you're going to look at the molecule here, your nitrogen is a triple bond. Okay? And if you are in a triple bond, you have a unique region where you can see it. So usually it's around 2000 to 2500. But as you could see here, this is around 2600 thing. In fact, one functional group that I have interaction ay yung tinatawag na cyano group. Okay? Because of the cyano group, it is a C triple bond N. So meron siyang unique peak around 2200 to 2300. So what we do, we analyze all, okay, all cyano containing compound that we can find in the lab and try to differentiate them based on kung ano yung naka-attach sa kanya. So yan yung way na nag-aano yung tinatawag nating IR. Okay? So if we're going to what we could look at the methods that we have discussed so far. So ano yung meron tayo? Yung UVB absorbance, yung fluorescence, which can also include the phosphorescence. And then meron tayong tinatawag na atomic spectroscopy. Yung atomic spectroscopy, dalawa yan, but the one that is common is the atomic absorption and the other one is the atomic emission spectroscopy. Okay? And last but not the least, yung tinatawag nating vibrational spectroscopy. Now, if you're going to look at the interaction, ito lang yung tinatawag nating atomic level. All are involving what? The molecule. Okay? And each of them has their own what we call use. But if you're going to look, let's say, at the molecular spectroscopy that you have there, each of these methods would give you some sort of a different perspective on a given molecule. Okay? So number one nga sinasabi ko sa inyo dati, you have a spectronic 20, you're, I think, good enough in the lab. Your lab is, we could say, useful. Because if you have a UV-based absorbance instrument or a spectrophotometer, you can do quantitative analysis. So ito quanti din, pero ito usually quali. Okay? In some instance, yung quanti lang dito ay yung mga gases. But you seldom use vibrational spectroscopy for quantitative analysis. Now, typically, if you're going to look at the optical components of all of this, meron kang ano? What's the number one thing that you need in any spectroscopic method? Anyone? Ano sa tingin niyo yung pinaka-important part sa spectroscopy? Anyone? Ano sa tingin niyo yung pinaka-important na part? For me, I would say it's the light source. Without the light source, you cannot do any analysis. Remember, how do we define spectroscopy? Ano yung interaction, ano yung tinatawag nating definition ng spectroscopy? The interaction of matter with light. So pag wala kang light source, there's no such thing as a spectroscopy. So I think that's the most important component dito sa optical instrument. Okay? And then after the light source, it can be the monochromator, it can be the sample holder, and then the detector, and then the readout system. So the way you analyze everything here, you have what? Either you use a calibration curve or ano pa? Aside from calibration curve, what other method that you can use to quantify and analyze in a sample using spectroscopic method? You can also use the so-called standard addition. So questions so far, class? May tanong?
Hi, Elmer.
Yes, ma'am.
Oo, kasi hindi nga masyadong common yung vibrational
Yun na nga po.
spectroscopy. So, saan kaya siya helpful? Anong applications?
Usually po, ma'am, sa organic chemistry.
Okay. Okay.
And if I'm not mistaken, you have 140, right? Sino dito may 140? If I'm not mistaken, I have classmates who's taking 140 because I'm an agricultural chemistry, wala kaming 140. So they tackle this what we call vibrational spectroscopy more on that. And if you watch the recording, I think I'm going to share to you the slides that we have. Yung isa ata kailangan yung gawin sa tawag dito spectroscopy is you're given some sort of a spectra and you try to elucidate is its structure. Like that one. Pero sabi ko nga sa inyo, for the analytical purposes, what we do, we're not going to give you this and you have to deduce this one. The way that we do it in analytical, so if you have this structure and this is the spectrum, you have to assign each of the functional group there. So hanggang dyan lang yung ano natin sa analytical, yung coverage natin. Because I know in 140, okay, this is where you, what we call utilize this method, okay? And the history that you have here, I think I can look at the beginning here. So it was designed, okay, for what we call determining the functional group. So yung history nito, it goes hand in hand with the NMR and the GC. Okay? So yan yung general schemes ng tinatawag nating IR. You examine what functional group is present. So 140, have you tackled this thing? Those are taking 140? Nasa Shriner ata to eh. Okay? But what I know is you're given what we call a spectra and you are asked to do here. Here in the US, they used it as early as basic organic chemistry. And usually when students get this spectra, ang ginagawa nila, nagla-library search na lang sila. And it will give you the structure. So at least in some of the discussion here, gaya nito, so ibibigay sa'yo yung quality hit. So it will tell you that, okay, 85% close to a certain compound or 84% close to a certain compound. And it makes it easier for you to determine it. And I remember some of my classmates before, they were given like a spectra, what they do. There is a database in AIST. It's a Japan based in Tsukuba. So what they do, they went to the database on that and try to look at the spectra of each of the compound that they think is the one that their unknown spectra structure is. So ganun yung naalala ko doon sa time na to. And you seldom, yes, tama si Ma'am Vicky, that you seldom discuss this in analytical because it's not really used for quantitative analysis. Okay. But I just want to share to you that there's a lot of tools that you can use for this one. So ang ano nga ang sabi nga natin sa IR, that's the first thing that you do if you want to determine the structure of your given unknown. Okay? And the good thing with this IR and the Raman, they would complement one another. So kapag hindi active sa IR, most likely is active in Raman, just like this one. As you could see here, ang taas dito, Okay, so CH, but here in the Raman, it is what we call mababa lang. And the way that you can differentiate them, if you use IR, usually you use what? Transmission. So the highest that you can have is a 100% transmittance. Tapos dito sa absorbance, you use, sa Raman, you use absorbance. Or in some books, they call it the Raman intensity. Okay. Now, what's the basic thing that you need to what we could know about this technique? So, IR, usually it's not useful if you have AQ sample. Why? Anyone? Ano bang meron yung AQ sample? You have water. And the hydroxyl group that you have there, what happened is it's going to give you a broad peak around 35 wave number. And if you have what we call a broad peak at 3500, so mamas out na niya kung meron ka mang NH or OH group doon sa sample mo. So the alternative there is you're going to use the Raman. Because the Raman, okay, will not be affected by the broad peak of the hydroxyl group. Okay, so you can see it here. Hindi pala kasi wala siyang hydroxyl group dito. This is a CH. So usually if you have an OH, you will have a big broad peak around here. And if you're going to look at the calculation, so balik tayo dun sa calculation natin. So this is your nitrogen. What's that? I'm trying to open a new file, yung water uli natin. So if we're going to look at the water molecule that we have here, so this is the way that we have. And if you're going to look at the IR, so look at the difference between the IR and the Raman spectrum. Now here, you would see that it's almost what? Sharp or narrow yung peak nila. But this is because this is a calculation that is based on gas phase. So if it's in the aqueous phase or liquid phase, usually mag-broaden or mag-widen yung peak ng dalawa. Okay? So iyan yung one, we could say, complementary application of the two methods. And then another one, if your sample is fluorescence, you cannot use your Raman. Okay? Why? Because based on my discussion here, the Raman is a scatter. So kapag mayroon kang fluorescence, it's more powerful than the Raman scattering. So it will mask out yung Raman scattering. So to circumvent the problem of fluorescence, you can use your IR. So yan yung ano namin dito, yung usefulness namin dito. So if we cannot use one of the method of vibrational spectroscopy, we're going to use the complementary method that we have. And if we go back doon sa nahanap ko yung paper na shinare ko, but I think I have to close some of the window. So if we go back here, so each of these peaks corresponds doon sa functional group ng structure ninyo. Okay? So usually the 3,000 will be what? Anong functional group sa 3,000? Anyone? Alkanes, specifically the what stretching you have in 3,000? Okay, yung CH. Okay? So depende pa yan kung sp3, sp2 or sp. Okay? So sp3 is what? CH3. sp2 is C double bond C with what we call dalawang hydrogen. Tapos pag sp, it's just a triple bond carbon with hydrogen. So if ever I'm going to ask question here doon sa quiz, ang ano lang natin is yung parang basic ng IR and Raman. So ano yung application niya? So one is an absorption method and the other one is a scattering method. So one is useful for aqueous sample and the other one's not useful for fluorescence. Okay? Yung OH and NH stretch, usually nasaan siya? If we're going to look at the handout, ipakita ko na lang sa inyo yung method dito. So you will know in case wala kayong 140. So this is where you can find those region. Okay, so you could see here all the stretching that involves the H is around 3,000. So this is the CH, the NH, and the OH. Okay, if you have the triple bond, it's around 2,000. Okay, to 2,500. Now, if you have the double bond, so when you say the double bond, usually this is the ring. So what are the ring? Yun yung tinatawag nating mga aromatic double bond. So it's around this one. Okay. And then if you have, this is all the stretching. So if you have the bending, it's around here. Okay. So the blue one here is the stretching, and then the green one here is the bending. And this is, we could say, where you can find this thing. Now, what can you say about those that has strong intensity? Tingnan nyo nga ito. Amine strong, cyanonitrile strong, alcohol strong, aldehyde strong intensity, and then NO2 strong, and then CH is also strong. What can you say about the common denominator, those that has strong intensity compared, let's say, doon sa medium o yung tinatawag nating variable? Okay, like this one, especially like this. Ano sa tingin niyo yung common denominator dyan? Anyone? This is just deducing yung observation ninyo based doon sa structure nila. Ano yung masasay nyo? Polar bonds. Okay, difference in electronegativity, polar bonds. Okay. So if you're going to what we call summarize, di ba yung polar bonds is also related to electronegativity? So the more polar the substance is, trying to go to the PowerPoint. The more polar the substance is, the greater or the stronger is the intensity of that functional group. Okay? So yun yung ibig sabihin nitong observation natin na lahat ng strong intensity usually, okay, it involves these polar bonds. So mas mataas yung electronegativity ng isa. So between carbon and hydrogen, so most likely papunta sa carbon. Okay. And if you have a carbon and the oxygen and carbon and the double bond oxygen, that's also one thing that you can do it. So that's one of the, we could say, practical aspect na ginagamit nila yung what we call IR. So for now, that's all that I like you to know about this, what we call vibrational spectroscopy. And as I have told you, unlike the other three, you seldom use this method in qualitative analysis. But this is what I can tell you. You know that we have a rover in Mars. Okay. One instrument that they attach in that rover is a Raman Spectrometer. Okay. I'm not sure if you heard that news before. And there's a lot of advantages in what we call using Raman spectrometer and IR spectrometer, especially right now, if you have this so-called portable Raman. Okay, are you familiar with forensic science? Familiar ba kayo sa forensic science? Do we have a major of that in the Philippines? One application that they use right now in forensic science is the use of this so-called portable Raman spectrometer. Ano sa tingin niyo yung i-analyze nitong instrument na to? Anyone? Ano yung ina-analyze natin sa forensic science? Usually what? You can have either illicit drugs or explosives. So ano yung functional group sa illicit drugs usually? Usually they have what? Okay. The one that they usually use is, it depends. Merong amine, merong aromatic rings. Okay. So what they usually do is having a library of these illicit drugs. So all you need to do is scan a sample and then let the spectra or spectrum run. Okay. And they will be able to identify. But the one that we usually train our students here at PACE is this, what we call explosives. What does the explosive contain? Anong meron usually yung explosive? And usually they use robotics that contains Raman spectrometer. If they suspect that there are explosives in a certain warehouse or house. Aromatic rings ba yun sa explosive? Ano yung letter na nakikita natin sa mga cartoons kapag meron tayong explosive? Okay, someone answer it. Yung tinatawag nating TNT. So ano yung ano doon sa TNT? Ano sa tingin nyo yung functional group doon? Okay? We have what we call the nitro. And I'm trying to get the paper that we have, okay, doon sa tinatawag nating sa nitro. So, what's that? Where's it? 2019. Forensic science. So I'm sharing to you here. So this is what we usually train our students here, okay, in forensic science. So since I'm the one in charge with spectroscopy, so what we usually do, we have these so-called mock explosives, okay? And we ask the student to analyze them. So what we have is just the nitro-containing substance. We don't use the real explosive. We only use one that also contains the nitro. And usually the nitro is the one that contains here, these two. Okay, so this high peak is a nitrobenzene. And then we have a nitrotoluene, okay, a nitrobenzaldehyde and 4-nitrobenzyl alcohol. So whenever we ask them to determine if nitro is present, all they have to tell us if it is possible presence of explosive or not. Kaya ang tawag nga namin mock explosives because we try to monitor them. Okay, so in terms of this, what we call illicit drugs, usually the way that we look at this is the methamphetamine. Okay, so if you look at the methamphetamine, their structure, they contain this aromatic ring. And an aromatic ring usually, okay, so if you're going to look at the structure of your methamphetamine, usually it looks like this. So we're looking for this one in the 3500 region because meron yang H. And then this one around the 1600 region. So that's, I think, the possible explanation that I can see for this method. And you can use it there in the Philippines. In fact, I'm awaiting the PNRI invitation. Kaso natakot na ako. Kasi it's the PNP. Tapos drug lord yung involved. Mahirap na.
Doon naman si Oliver. Bahala siya sa'yo. Sa protection mo. Sa bodyguard mo, dapat meron kang personal bodyguard. Sabihin mo kay Oliver.
Nakakatakot. Kasi yan nag-invite ko si Sir Caloy Arcilla sa PNRI. Mag-deliver daw ako about the use of Raman Spectrometer sa tawag dito, yung illicit drugs. Tapos sabi ng friend ko, gusto mo makipag-deal doon? Mga drug lords yung makakalaban. Because I
Pero
think
sina Oliver, nagpapa-upgrade ng kanilang lab. So most likely baka bibili sila ng Raman.
Baka nga. Kasi yun din po yung ano dito, yung mga faculty ho namin sa forensic science, mga taga-crime lab, mga NYPD. So usually pag ano na sabi nga sa amin, ipi-phase out na namin yung benchtop. We will go more on the portable one kasi parang pwede daw dalhin sa on-site analysis. I
Sa
don't,
scene of the crime.
opo, yun na po. I don't know kung alam ninyo mga students yung nangyari doon sa Aurora, Colorado during the Batman premiere. I think it's around 2013, 2014, tapos may nagwala. So when they, what we call, went to the person's home, they use robotics to determine if there are explosive. And there was an arsenal of explosives. Okay, so yun yung parang in nila ngayon dito. They try to do everything on site. And with the advent also of the computer, yung ang ano nga noon you just put your sample in the vial, and then just like the size of a cell phone, i-dip mo lang yung sample mo, yung vial with your sample doon sa device nila, and they can already give you what sample do you have there based on the spectra. So i-ano lang nila doon sa library. So yun yung parang nagiging in ngayon dito, and they're trying to use it now. I know a person in University at Albany, which is SUNY. So they're trying to develop it in crime lab using yung mga specimen na nakukuha nila, like DNA. Okay, so I don't know how they will be more ano doon yung paano nila i-update, but that's the trend that we observe right now. They're trying to make everything portable. Some of you may be going, kasi karamihan yata ng graduate natin, like Lieutenant Colonel Oliver Dechitan, who is a batchmate of mine, they end up in the crime lab. So the PNP is trying to upgrade their capacity there.
Actually, marami silang opening. Kaya kung gusto nyo, pwede doon. At mahalang sweldo doon.
Mhm.
Not less than 45,000 ata. But you have to do a training. You have to undergo training, yung initiation nila.
Yeah.
But yun, yung mga malalakas ang katawan, na matatapang, you're always welcome. Kasi maraming vacancy sa PNP.
You will end up as a police official with rank, officer's rank. So question, yun lang yung nakikita ko, I think, use of this method there in the IR. I included it because I have a person experience on that one. And if you have time, I think mas okay yung example na binigay ko doon sa isang link. The talk that I deliver with Paase. Question? And another thing pala yung dito, usefulness dito is it can tell you the nature of environment kung nasaan yung molecule mo. Okay? Isa pala namin ginamit dito under Dr. Desamero, okay, which is also a UP alumna. We're trying to look at this so-called amyloid formation. So when we're talking about amyloid formation, ito yung mga neurodegenerative diseases, including diabetes, yung tinatawag nating Alzheimer's, and Parkinson's disease. So usually, isa sa common traits ng mga diseases na to yung tinatawag na protein folding. So when protein folding happened, we found out that there's so-called aggregation, yung formation ng solid particle. So yung aggregation na yun yung similarity dito sa amyloid formation. So the way that they try to deduce or what we could implement some sort of a therapeutic solution to this amyloid formation is to develop something that prevent the aggregation. So yung tinatawag nating amyloid inhibitors or amyloid formation inhibitors. And what they usually do is just the short chain of the protein where or the protein that cause those what we call amyloid formation. So for instance, for diabetes, they found out that it is caused by amylin. So this is a 37 polypeptide. So one thing that when I was a postdoc that worked on the lab, they look at this chain. So this is from 22, 3, 24, 25, 6, 7, 29. So yan yung tinatawag natin amino acids 22 to amino acid 29 in the amylin. So ano yung ginawa nila? They look at the phenylalanine. So you know phenylalanine is a ring. So what they do is they change the functional group that attached to the phenylalanine. So instead of a hydrogen, we look at the different functional group and we found out that there's no amyloid formation that happened. Okay, so that's one way that they try to what we call group. And the way that we look at this one is using the IR and the Raman. Now, I'm not sure, have you heard the term beta sheet formation? May 161 na ba kayo? Class? Are you familiar with the beta sheet formation like alpha helix? Okay. Ito yung parang conformation that protein, the protein would have. Okay. So one characteristic of the protein aggregation is the formation of the beta sheet. And the beta sheet would have a signature peak at around 1675 wave number. So ang ano dito, kapag nakita mo yan, so most likely you have an amyloid formation, okay? Or you have their aggregates or your protein starts to fold. So that's one diagnostic that they usually use to see kung meron ka ng onset ng either diabetes, Alzheimer's, or Parkinson's. There are a lot. That's why malaki yung funding dito kapag nag-ano ka yung propose ka. Okay? So I think that's the last thing I could say about this application of the method. So tanong, before I will let you vote kung ano yung gusto niyo yung sa quiz, isang mahabang quiz that contains all modules or several quizzes that contains the sub-module. Tanong?
Siguro mas helpful yung
Konti-konti.
per module o para hindi ma-information overload.
Kaya nga ho.
No,
Para at
class.
least, kasi
Thumbs up nga kung gusto niyo nung...
meron pa akong ginawang poll question.
Okay. Meron? Okay.
Ayan, no. Sagutin
Okay.
nyo. One quiz covering all module 4 or several quizzes. Na lahat sila doon. Imbes na let's say 2 oras straight, so gawin natin let's say 20 minutes, 20 minutes, 20 minutes. Yun nga lang, huwag kayong magpalit ha. Baka mamaya sabihin nyo gagawin ko itong module 4.1 tapos ikaw module 4.2 tapos swap tayo. Huwag kayong ganun ha. Because what will happen is parang time interval din yung gagawin ko. So let's say Friday ito lang and then Saturday ito lang, Sunday ito lang. Parang walang leak. I think that's the safe way to do it. So at least I think overwhelming several quizzes made of each what we call sub module. So maybe I'll try to set it up para kung madali man ako ng booster shot ko, meron kayong gagawin this weekend. We still meet on what we call Wednesday. So we will start with LC and MS. So yung tentative schedule, kapag multiple short quizzes, I think Friday will be what, 4.1? And then Saturday is 4.2, and then Sunday is 4.3. So we will just make around 5 questions per what we call short quizzes. Is that okay? Okay ba yun? 5 questions for how many minutes? Gano'ng katagal gagawin niya sa 5 question?
30 minutes, okay na, class?
Okay na sa inyo 30 minutes o masyadong mahaba yun? So we will give you 30 minutes, okay?
Ayan, sige.
So i-email ko kayo by tomorrow because I think less than kalahati lang, and I will show you this schedule, okay? So most likely 1 on Friday, 1 on Saturday, 1 on Monday, and maybe 1 on Tuesday. So lahat yan, take 5 questions lang. Okay? So this is covering 4.1, 4.2, 4.3, and 4.4. So question. I hope I can grade the other stuff this spring, what we call, we have a break starting on Wednesday, but I will also have my booster on Wednesday. So we will see. Alin yung mauuna. Because the word that I heard is not really good for me. Those that I heard took Moderna, if the second shot is worse, okay, the booster shot is more horrible. So I'm not sure what will happen. Kasi depende naman daw eh. But I think during Wednesday night, I'm still okay on that time. Okay. I will have my shot around 5 o'clock dito sa isang pharmacy. So I don't know how your vaccine rolling there at this time.
Siguro next year pa yung mga boosters namin kasi mga mid-year kami nagkaroon eh. Yun yung mga senior. Pero ito mga batang to, ano na eh, mga September, October na sila eh. Kaya mga April, mga March, April pa yung booster.
So tanong, sige po ma'am, sa Wednesday, sa Thursday uli. Wednesday night kasi dito.
Sige, thank you, Meng. Okay, bye.
I-share ko na lang yung link ng recording.
Sorry, class ha, meron akong proposal defense. See you at 2 o'clock sa KKP.
Baka hindi ko ako kapunta alauna ho dito.
Oo nga pala, oo. Sige. Yun na lang ating mga children. Sige. Okay. Bye-bye.
So may tanong pa. So there's a talk, I think, at 2 o'clock in KKP. One is from industry and one is about teaching. Yung talk ko bukas pa. I'm still going to prepare them after our class tonight. Okay. So somebody message me that the link was not sent. So please ask the secretariat because I sent your name. Okay. Telling them that, in fact, I still have 6 slots, okay, that is available, pero binigay ko na lang doon sa kanila. Okay?